Alright, so today we're going to talk about parallel and perpendicular lines and maybe also some word problems dealing with linear situations. Okay, so starting with parallel lines. Here I'm drawing a line, and then I'm going to draw a line that's parallel to it. Right? Parallel lines, they sit kind of at the same angle, they never intersect. That's all things we learned about in geometry. Algebraically, though, what do we say about parallel lines, like with their slope? What do we know about that? Yeah, same slope. Right, and then perpendicular lines, that's going to be, maybe a little more interesting. I'm going to draw my coordinate axes. I'll draw one line here. I'm going to draw a line that comes in perpendicular to it. So remember from geometry that, if we say the two lines sit perpendicular to one another, they have an intersection that's like a right angle. And the relevant fact over here is that perpendicular lines slopes multiply together and equal -1. The way that we end up calculating those, you might remember this from Algebra 1, is that, if we have a line with a given slope, what we do is we make it negative and we flip it. We're looking for the opposite reciprocal. Okay. So that's really because of the fact that the slopes of perpendicular lines multiply to -1. And the reason for that is maybe something that's like a little beyond the scope of this course. And so here we have, kind of our first type of problem is going to be determine if these lines are parallel, perpendicular, or neither. Okay. So what I recommend doing is just when it's given to you in standard form, solve for y. Put it in y equals mx plus b because then you're looking right at the slope. The slope is that hint. So what I'm going to do is I'm going to say, all right, for this one, 2y is equal to 3x plus 6. I'm going to divide both sides by 2. And that's y equals 3 halves x plus 6 divided by 2 is 3. And we got to divide everything by 2. And then over here, I'll add 4y to both sides, and I've got 6x equals 4y plus 8. And I'll subtract the 8. I'll get 6x minus 8 equals 4y. Then I divide everything by 4, and I'll get 6 divided by 4, which is 3 halves. X minus 2 equals y. You see here we have the same slope. So I'm going to conclude that the lines are parallel. Okay. Next I'm going to do the one kind of in the bottom right on your sheet. And again, I'm going to solve for y. So over here I'm going to add 4x to both sides, and I'll say that 2y is equal to 4x plus 12. Then I'm going to divide both sides by 2. Have y equals 2x plus 6. And over here, I'm going to subtract the x from both sides. 2y equals negative x plus 6. Divide in half, and I'll have y equals negative 1/2 of x plus 6 divided by 2 is 3. Okay. So I can see right now, I've got slope of 2 and slope of 1/2. They're not equal. So if the slopes are not equal, there's a chance that they could be perpendicular, but there's also a chance they could not be perpendicular. So what I'm going to do is I'm going to take the slopes. If the first slope is equal to 2 and the second slope is equal to negative 1/2, and I just try multiplying them together, I've got 2 over 1 times negative 1 over 2 equals negative 2 over 2, which is the same as negative 1. So since the slopes multiply together and equal negative 1, we conclude that the lines are perpendicular. Or you could just look at it and say that 2 and negative 1/2 are opposite reciprocals, and that's basically enough to conclude that the lines are perpendicular. I'm going to do a third one, just to kind of, hopefully the bottom left one is neither. I didn't do it yesterday. I did the top right one, and it was neither, but it's neither as well. Just from looking at the numbers, I'll show you a different way you can approach this. Something I told y'all last time was that if the line is given to you as ax plus by equals c, then the slope of that is negative a divided by b. And, if you remember that, then good for you. If you feel like that's just one more thing to remember and there's already quite a bit of stuff you need to remember in your life, then you can always just solve for y like I have in the past too. What I'm going to do is I'm going to use that. So for the first slope, I'm going to use, that's negative 8 divided by 1. And then for the second slope, I've got negative 2 divided by negative 8. So I've got negative 8 and positive 1/4. These are not equal. They're not opposite reciprocals. If I multiply them together, I'm getting negative 2, so they're not perpendicular. So I can conclude that the lines are neither parallel nor perpendicular. Close right. Okay, these more examples along the same lines. If you need more practice with this, go ahead and do them. But we're not going to do that. Find the value of a or b so that the lines are parallel or perpendicular, as it says. Okay. So again, my advice is going to be solve for y. So on this one, when I have ay is equal to x plus 2, a is just some number that we're going to figure out. We're going to divide both sides by a. So y is going to be equal to 1 divided by a times x plus 2, which is going to be 1 over a multiplied by x plus 2 divided by a. So over here, it's already solved for y, so I'm just going to say that the second slope is 3. See that right there? Now, if they're parallel, I need the slopes to be equal. Okay, so what I'm going to do is I'm going to say that here, this 1 over a needs to be equal to 3. So I can do it like that, and I can cross multiply, and I can say that 3a is equal to 1, therefore a is 1/3. Okay, and that would kind of be, this would be a good point to kind of stop, think to yourself, is this reasonable? if I had 1/3 of y is equal to x plus 2, and I wanted to solve for y, what I would do is I would multiply both sides by 3, and that would give me 3x and like 6 or something. But either way, I'd have that 3x, and it would match up with the other 3x, and I could conclude that the lines were parallel. Over here, we're going to make this one perpendicular. So what we're going to do is we're going to say that the slopes multiplied at negative 1. So I'm going to start over here by solving for y. So I've got 2y equals negative bx plus 2. I'm going to divide everything in half. Here I'm going to subtract 4x to solve for y. So I've got that the first slope is equal to negative b divided by 2, and that the second slope is equal to negative 4. Now I know that in order for them to be perpendicular, I need m1 multiplied by m2 to equal negative 1. So I'm going to set up that equation, and then I'm going to substitute on m1. I know that m1 is negative b over 2. And I know that m2 is negative 4 over 1. And it's that negative b times negative 4 is positive 4b divided by 2 equals negative 1. So I'll cross multiply, bring that back up here. I've got negative 2 equaling 4b. So when I divide by 4, I get b equals negative 2 over 4, or negative 1. Okay. Honestly, I think this is probably like the most difficult type of problem that we're going to see today. So I'm going to have y'all try the next two. Work the next two. I'll freeze it. You can check your answer against mine. Question. Okay, so check rating's fine. I pretty much did it the same way as I did the other ones, but you know, if you've got your own way of doing it, and you're basically finding slope of each of the lines and figuring out a way to make them parallel. Okay, so we've got 2 points that uniquely define a line, and they're going to ask us what would be the slope of a parallel line, what would be the slope of a perpendicular line. Yeah, and this is kind of, a classic question. Very straightforward to the point about the slopes of parallel and perpendicular lines. Okay, so we want something that's parallel to a line that's going between the point 1, 2, and 6, 5. Okay, so we need to find the slope. We're going to do rise over run, so we'll do 5 minus 2 over 6 minus 1. It's going to be 3/5. So the slope of a parallel line, I guess those lines aren't parallel, so running into each other, but better. Slope of a parallel line, it's about as good as you can get. It's going to be 3/5, right? Because parallel lines have equal slopes. Perpendicular, start by finding the slope in between the 2 points. Maybe this time I'll do y1 minus y2 over x1 minus x2. Remember last time we said that's the same thing. It doesn't matter which one you choose, as long as we're consistent. Right? We're going to do -1 minus 3. We have to do 3 minus -3. Otherwise, we'd be off by a factor. Right, so I've got that's 6 over -4. So if the slope of our line is 6 over -4, then the slope of a perpendicular line would be, okay, we're going to flip it, and then we're going to multiply by -1. So it would be positive 4, 6. Okay, again, here it is. You do it. I'll come around and see if anybody needs any help. So you can check your answers up there front. And is anybody not okay with what I did right there? Yeah. it's kind of like a level down from solving for a value of an unknown quantity that will make something parallel or perpendicular, because you have to know what causes two lines to be parallel and perpendicular, and you have to solve this. You really are just doing one line. Finding equations of parallel and perpendicular lines, basically they probably pass through a point. It's going to be the type of information they're going to give. So really the best thing to do is kind of, go through the statement of the question. Parallel to y equals 3x plus 2. Well, so it's parallel to a line that has slope 3. So that means that the slope is going to have to also be 3, because parallel lines have equal slopes. And like I was saying earlier today before the quiz, this is one that you could set up with y equals mx plus b. We know what m is now. We could solve for b using the point 2, 3. Or we could go to point slope form and then distribute and work that around. It doesn't matter. Okay? Maybe right here I'll do it both ways. Moving forward, you can do it however you like. So if we wanted to start with point slope form, we would use our point here, this 2, 3. We would use the slope of 3, and so we'd have y minus the y value of the point we know. It's equal to the slope times x minus the x value of the point. They're asking for it in slope-intercept form, so I'm going to distribute the 3. Y minus 3 is equal to 3x minus 6. And that y is equal to 3x minus 3. Or I could have gone a different direction and said, well, I know that they want slope-intercept form, so I'll just set up for that right now. Y is equal to mx plus b. I said that, well, if it's parallel to a line with slope 3, it will also have to have slope 3, so I'll say y equals 3x plus b. And then I'll use the point 2, 3. I'll let x equal 2 and y equal 3. I'll say 3 is equal to 3 times 2 plus b. That's 3 equals 6 plus b, meaning that b is going to have to be negative. So either way, I'm going to get y equals 3x. How do you want it? Alright, I'm going to move on to, I think it's the next page for y'all. I'm going to do these two. Because these are maybe, a little different. Okay, so we've got, we see perpendicular to 4x minus 2y equals 2. What is the slope of 4x minus 2y equals 2? I'm going to solve for y. So it's perpendicular to a line that has slope 2. Right, we see that the slope is right there, it's 2. So that means that the slope will have to be the negative reciprocal of 2, so negative 1 divided by 2. And passing through x-intercept of x equals negative 3. Okay, well what that means is that the point negative 3, 0 is on the graph of the line. Right, if we have intercept of x equals negative 3, that is the point negative 3, 0. So I've got a slope and I've got a point. So again, I'll write it in point slope form. That's the one we always forget about point slope form. So when I write it like that, I'll have y minus 0 is equal to negative 1/2 of x minus negative 3. Alright, so now on to the stated problems. I'll give you some sort of situation. I'm going to have you probably write a linear function and do some stuff with it. So an hourglass has 10 grams of sand when it is first flipped. Right, so I'm going to make a little table of values. So I've got grams of sand, and number of minutes. So I presume we're talking about, the top of the hourglass, right? We're talking about the amount of sand up here, right? So, because that'll decrease over time. The total amount of sand is going to stay the same unless the cold bottom. But so at 0 minutes, there are 10 grams of sand. And after 2 minutes, there are 7 grams. So we're going to, the amount of sand is going to be y. Up there. And minutes is going to be x. Okay. So what we're going to do is, well, since we have a place where x equals 0, we have a y-intercept. So if we could just, get a slope, we'll be able to write down an equation. Yeah, and as far as the interpretations, I'm going to do those after we write the equation. All right, so let's get an equation. First, we'll need a slope. That's going to be rise over run, 7 minus 10 over 2 minus 0. It's going to be negative 3 over 2. So our equation is going to be y equals negative 3 halves x plus b, the y-intercept. But then I see over here, when x is 0, y is 10, so that's going to be the y-intercept. So negative 3 halves x plus 10. Okay, and that kind of makes sense because at the beginning you start with 10 grams, and then over time, as x gets bigger, we're multiplying by negative 3 halves, we're losing sand. So interpret the slope of the equation. So slope. So when they ask me to interpret the slope is a rate of change. It's the rate of change of y with respect to x. So it's the rate of change of the amount of sand with respect to time. The units of the slope are going to be the units of y divided by the units of x. So it'll be in grams per minute. So what I might say is that, if it's negative 1.5 grams per minute, you could also say that every 2 minutes, it loses 3 grams. Or you could say, the rate at which sand is falling is 3 halves grams per minute. That's fine too. Okay, they ask us to interpret the y-intercept. I know it's an x, but sometimes they'll ask you to interpret the y-intercept. Almost always, the interpretation of the y-intercept is something like it's the starting value, okay? Because it's where x is 0. X is the number of minutes. Y-intercept is the amount of sand we start with. Now the x-intercept, that's a little more interesting. Okay, it says first find the x-intercept. Okay? So the thing about an x-intercept is that y equals 0. Always, right? Here at an x-intercept, y is 0. So I'm going to say negative 3 halves x plus 10 equals 0. And in order to solve for that, I'm going to subtract 10 from both sides. I'll get negative 3 halves x equals negative 10. Then I'm going to multiply both sides by negative 2 over 3. And that's going to give me x equals positive 20 divided by 3. And x is measured in minutes, so this is a number of minutes. So what would you say that this means in the context of the problem? Yeah, well, so after 20/3 of a minute, just something like, I don't know, like 6. It's going to run out of sand. But that makes sense because y is the amount of sand. And we're saying when y equals 0, well, that'll be when all the sand is gone. Okay, so